Welcome to 5 random questions from an AQA Further Mathematics Level 2 paper. This is a non-calculator paper. Okay, so let's look at the first question. So a fifth of 3a is 35% of a plus 6. We've got to find a. Well, I'm going to start just by putting this more formally in algebra. So a fifth of 3a is the same as saying 3a over 5, and we're told that that's 35% of something. Well, 35% is 7/20. Okay, so it's 7/20 of a plus 6. Now if I take the left hand side and multiply numerator and denominator by 4, I will get 12a over 20, and over this side I've got 7 lots of a plus 6 over 20 as well, you see. So now they're both over 20, I can just cancel the 20, and then I'm just left with 12a equals 7a plus 42. Okay, multiplying out the bracket and taking away 7a, I've got 5a equals 42. Well, I just need to divide by 5 to get a, and that's equal to 8.4. Okay, and that's the answer. Next question. Two straight lines that bisect each other. That means that B is the midpoint of AC, and it's also the midpoint of PQ. Okay, so what I would do here is to find the coordinates of B, it's the average of the x coordinates of A and C and the y coordinates of A and C. So if to write it formally, I would write it like this. I would say B equals, okay, and when I say average, I mean the mean. So it's 6 plus -4, adding the two x coordinates together, and dividing that by 2 to find the middle of those. And the y coordinate is going to be 5 plus 1, and that's also divided by 2 to find the midpoint. Okay, and that can easily be seen to be 6 minus 4 is 2, so 2 over 2 is 1, and the y coordinate is 5 plus 1, 6 over 2, which is 3. So B is the point 1, 3. I'm just going to write that down on the diagram. Okay, now it could easily be worked out what Q would be, because I could just go from -2 up to 1. That's -2 to 1 is 3, but I'm going to do it formally, and I'm going to say that the point B, which is 1, 3, okay, so this point B is the average of the coordinates of Q and the coordinates of P. So I'm going to call Q the point x, y. Okay, so this is a sort of formal algebraic way of doing it, and therefore I can say that that must equal, well, it's going to be x over x minus 2 over 2. Okay, so I'm using x here and the -2 as the x coordinate of P, you see. And that's got y minus 1, or y plus -1, because that's the coordinate, the y coordinate of P, over 2. And I just solved two little equations to find what x and y are. So x minus 2 over 2 equals 1. So therefore x minus 2, well, if I write it formally, it's that. Double both sides, x minus 2 equals 2. Okay, so therefore x must equal 4. And similarly, I've got y minus 1 over 2 equals 3. So if I times both sides by 2, y minus 1 is 6. Y therefore must be 7. Okay, so therefore Q is the point 4, 7. And if you look at the diagram, that seems about right. Okay. Third question. Let's have a look at this one. Factorise fully. Okay, so you've got to look for the highest common factor of both terms. Well, it's got x squared there and x to the 4 there, so it's x squared, and it's also got y there and y there, so it's x squared y. Okay, so x squared y is the highest common factor of both terms. So what's left over? Well, it's just going to be x squared to give me the x to the 4, and it's also going to be 3y squared, and it's a plus sign in the middle. If you multiply that out, you will see that it returns to this. So that's a very straightforward question there. Now this one looks like it's going to be a complicated algebraic fraction, but it really isn't, because you notice that there's a common factor of 2 here. So what I'm going to do is write this as 2 lots of 5x minus y. Okay, and on the denominator I have a common factor of 3. Okay, and if I take that out, I'm left with 3 lots of y minus 5x. Okay, now the two brackets there, one is just the negative of the other. So I can show that just by putting a negative sign in front of the 2 and multiplying that bracket by minus 1 to give me y minus 5x, you see. Okay, and then underneath that I've got the same that I already have. Okay, so I've just got that again. And now all I need to do is just say, well, cancel out the two brackets, which are now exactly the same, and I'm left with negative 2/3. And that's the answer. Okay, this question is about the points O and P. Okay, so P is the point 2, 3. Okay, this is the point O here, the origin. This is the point 2, 3. Okay, and it's saying that OP is the radius of a circle. Now that gives us two possible options. Either the center of the circle is at O and the circle goes through the point 2, 3, or the center of the circle is at 2, 3 and the side of the circle goes through the point O. Okay, so I've got some illustrations here of what's going on. So if I bring that in there, okay, we can see that's one possibility where the center is about at 2, 3 and it's going through the point O. The other possibility is this one where the center is at O and it's going through the point 2, 3, roughly like that. Okay, so you can see what's going on there. Now, in either case, the radius is the same, because the radius is simply found by using Pythagoras. So if I just draw a line here, okay, you can see that the length of that line there, r, I call that r, would be equal to the square root of 2 squared plus 3 squared, okay, which would be the square root of 13, which is the radius of both of those circles. Okay, so that's fairly easy to find. I'll just put that like that. So it's root 13. Now, the equation of a circle that goes through the origin, with the center rather on the origin, is x squared plus y squared equals r squared. Well, r squared is the square of this, which is just simply 13. So that's the equation of the circle. I'll call it C1. That's this one here. Okay, so that equation I've just written down is for circle 1. The other possibility is circle 2, and that's simply displaced by 2 to the right and 3 up. So the equation of that would be x minus 2 squared, okay, plus y minus 3 squared equals 13, because it has the same radius. And that is the equation of the circle C2. Okay, so that's the answer to the question, because it wanted the equations of the two possible circles that would have a radius joining O and the point P together. P is this point here. Okay, and that's the end of that question.